Let's solve a problem to find a volume of a solid, which is obtained by rotating this region around between the three curves around the y-axis. So first of all, we need to draw all the curves. In order to do this, let me put the coordinates to here. So the first curve, y is equal to the x cube, is basically looking like this, right? Roughly. So x is equal to the zero curve. It's like all the points where the coordinates, x coordinates are equal to the zero. For example, this point or this point or this point, for all of those points, x coordinates are equal to the zero. So basically, this is the y-axis. Y-axis is actually x is equal to the zero curve. So this is the x-axis, which is the y is equal to the zero curve. And there's a third one, y is equal to the 8. So let's say this is the 8, and y is equal to the 8 is going to be this line. So let me draw this was the red one as well. So this line. Good. So this point, the coordinates of this point is going to be 2 and 8, right? Because if you substitute the 2 to this curve, y is going to be equal to the 8. So we have to rotate this region, so which is bounded by the three curves, right? By the three. So we have to rotate this around the y-axis and find the volume of a solid which is obtained by rotating this. So basically, if you rotate this, we are going to get this kind of solid, which is going to be kind of a circular one, right? So we have to find the volume of this. So again, we're going to do this by creating the slices. But now, previously, we did the vertical slices, and the area of the slice depended actually at which point on the x-axis we made the slice. So now we're going to make the horizontal slices, and the area should depend on the y, because it depends at which height we made the slice, right? For example, if you decide to create a slice to here, at some point y is equal to the 1, for example, then the area is going to be this one, the smaller one. While if you choose this point, y is equal to the 4, for example, then the area is going to be bigger, right? So now this function of the area is going to depend on the y. So at which point I'm choosing, so at which point I'm cutting this solid. Okay, so no matter at which point we're doing this, so the area of the slice is going to be always a circle, and the area of a circle is equal to the radius of the circle in the square multiplied to the pi. Well, do you see? So if I know the coordinates of this point, x and y, which coordinate is going to be the radius? So previously, the y coordinate was the radius when we made the vertical slices. So while now the x coordinate is going to be this radius, right? So basically, if I know the y, because I'm deciding to make a slice, for example, at the y is equal to the 1, can I find the x? Or for example, if the y is equal to the 4, can I find the x coordinate of this point? X and y coordinates. Yes, we can do this because we know the equation of this curve. So the equation of this curve is equal to the y is equal to the x cubed. So we have to find the x from here, actually. So if you find the x, is going to be the cubic root from the y. So basically, if the y is equal to the 1, then x is also equal to the 1. So the coordinates of this point is equal to 1 and 1. If the y is equal to the 4, I have to just substitute the 4 to here in order to find the x coordinate, which is going to be cubic root of the 4 and 4. So basically, so from 0 until 8, I can create any slice, and I can find the area of any slice because I know its radius. So in general, so the function of the area is going to be equal to the radius in the square multiplied to the pi, and this radius actually is equal to the cubic root of the y. So this is in the square multiplied to the pi, which is going to be a y square 2 divided to the 3, right? Because yt, it means the y square. 1 over 3 means cubic root multiplied to the pi. So this is the function of the area. So what we have to do is we have to create a lot of slices and we have to just sum the areas of those slices. So the volume actually is going to be equal to the integration of the function of the area with respect to the y now, and we have to do this from 0 until 8. So the y is going to change from 0 until 8. So we just need to put everything together to here. So this is going to be the integration from 0 until the 8, y in the power of 2 over 3 pi dy. So we are going to take the y, a pi out of the integration, and we have to integrate this y. So we're going to just use the formula of the integration of the power functions. It's going to be y in the power of 2 over 3 plus 1 divided to the 2 over 3 plus 1. And this is all multiplied to the pi. We have to put the 0 and 8. So if we add the 1 to the 2 over 3, it's going to be 5 over 3. It goes to the up, it is going to be 3 over 5 multiplied to the pi, multiplied to the y in the power of 5 over 3, right? So basically, so if so now we have to substitute this 0 in 8. So it's going to be 3 over 5 pi multiplied to the 8 cubic root of 8 actually in the power of 5. So minus 3 over 5 pi 0 cubic root of the 0 in the power of 5. So the second term actually is equal to the 0. The first term here is cubic root of the 8 is equal to the 2. 2 in the power of 5 is 32. 32 multiplied to the 3 is going to be 96 over 5 multiplied to the pi. So this is going to be the volume of the solid, which is obtained by rotating this region around the y-axis.